It is roughly 5,000 years ago on the Orkney Islands, north of Scotland. The wind suddenly turns cold. Seabirds disappear inland. The Atlantic darkens, and a wall of rain moves toward your settlement. You have no forecast, no concrete bunker, and no phone alert politely translating to, nature is about to throw your house across the village. So when the sky became dangerous, how did ancient humans actually survive deadly storms? They did not wait until the first roof beam snapped. Survival began with noticing changes early, choosing the safest shelter, protecting fire and food, and keeping away from water that could rise faster than a person could run. Archaeology rarely preserves a written emergency checklist, so we must separate direct evidence from reasonable reconstruction. Ancient buildings still reveal a great deal. At Skara Brae in Orkney, a Neolithic farming community lived in stone houses between roughly 3,100 and 2,500 BCA. The houses were built from flat stone slabs, set into large mounds of compacted household waste, and connected by roofed passageways. Each room had stone beds, storage furniture, and a central hearth. This was not a random pile of huts facing the Atlantic. It was a partly buried village designed by people who had already met Orkney weather and disliked the introduction. When a storm approached, the safest response was probably fast and practical. Leave exposed fields, bring essential tools and food inside, close the low entrance, and gather around the hearth. The covered passages allowed people to move between homes with less exposure to violent wind and rain. Thick stone walls and surrounding middens stabilized and insulated the buildings. Archaeologists did not discover a Neolithic storm manual saying, Step 1, rescue the fish. Step 2, panic efficiently. But the settlement's design made sheltering together, preserving heat and protecting supplies possible. Storm survival was built into everyday architecture. Now travel to Mesopotamia in the 7th century BCA, where the problem was different. Many cities depended on mudbrick, a wonderful building material until the sky began pouring water on it. In Nineveh, scholars under King Ashurbanipal preserved thousands of cuneiform texts in the royal library. Among Mesopotamian scholarly traditions was Enuma Anu Enlil, a large collection of celestial and weather omens. Surviving tablets and commentaries recorded thunder, wind, clouds, and other events, then linked them to possible dangers for the kingdom. Ashurbanipal was the ancient world version of someone who saves 30,000 browser tabs because one might become useful later. In this case, some did. The records show that experts watched the direction and timing of weather events instead of treating every storm as completely unpredictable. A warning could give farmers, boatmen, officials, and households time to stop travel, secure goods, and move away from vulnerable river edges. Once rain arrived, survival depended on buildings, drainage, and maintenance. Mudbrick walls needed protective plaster, roofs needed repair, and stored grain had to remain dry. Did Mesopotamians also perform rituals to prevent disasters predicted by omens? Yes, they did. Their response mixed observation and engineering with prayers and offerings, because even 4,000 years ago, people wanted both a practical solution and someone in management to complain to. The texts prove the forecasting tradition. The exact household routine is partly reconstructed from Mesopotamian architecture. Ancient China shows the largest version of the same idea. Do not merely survive tonight's water. Redesign where tomorrow's water will go. Around 256 BC, the Qin official Li Bing directed construction of the Dujiangyan system on the Min River in Sichuan. Instead of blocking the river with a conventional dam, the project divided its flow, diverted water toward the Chengdu Plain, reduced sediment buildup, and helped control flooding while supplying irrigation. Li Bing was the rare public official who looked at a recurring natural disaster and chose infrastructure over a speech. Dujiangyan could not stop thunder or wind, but it reduced one of the deadliest consequences of severe rain: uncontrolled floodwater. For communities downstream, preparation meant keeping channels functional, avoiding dangerous low ground, moving people and valuable animals away from rising water, and storing essentials above flooded floors. Some immediate actions are sensible reconstruction rather than preserved instructions, but the system itself proves that ancient governments understood a crucial principle. Water becomes less deadly when it is given somewhere safer to go. Here is the modern contrast. Tyros 1, the world's first weather satellite, was launched in April 1960, allowing humans to view large weather systems from space. For nearly all of human history, the warning screen was simply the sky. Zoom out, and the ancient response was not mysterious. Watch early. Get under strong cover. Protect fire, food, tools, children, and animals. Stay away from exposed ground and rising water. Then build the settlement so the next storm does less damage than the last. Ancient people could not control the atmosphere, and neither can we. Their real advantage was memory shared across generations. Which clouds meant danger, which ground flooded first, which walls survived, and which mistakes should never be repeated. A storm was natural. Whether it became a catastrophe often depended on whether a community had prepared together. The next time your phone warns you to seek shelter, remember that the alert is modern. But the decision to look up, believe the warning, and protect one another is ancient.